Iteration speed is a superpower. Our mission is to bring that superpower to anyone solving problems in the physical world. That's why we're working on the toughest problem in manufacturing, to make any part at the push of a button. Let me show you what that looks like. This is a flying wing drone that I designed, and I wanted to make it aerodynamic and really easy to assemble. So I worked on these print-in-place flexural control surfaces. Now, something like this takes a lot of iteration to get right, but essentially all the time I worked on it was spent in CAD. And every time I wanted to see a version of it in the real world, I was able to press print and have a complete iteration within a day. That's any part at the push of a button. Even though we didn't say it, we've been working on this idea since the beginning. When we started, we were fresh out of school and didn't have the resources to take the challenge head on. So in the first phase of our company, we took these steps. We built the world's first professional desktop 3D printer. Then, we built a powerful ecosystem of materials and post-processing. Then, we expanded into new processes like SLS to repeat the cycle. As a result, we have over 150,000 printers in the field and have the best-selling SLA and SLS 3D printers, each surrounded by complete ecosystems of high-performance materials and post-processing equipment. This gives us the platform to take the challenge of any part at the push of a button head-on. It needs to be faster, cheaper, and easier to get parts. But we don't just need any parts. We need strong and durable parts. And the benchmark for us are thermoplastics like polycarbonate and ABS. Let me show you what that looks like.
That was pretty awesome. I'm Adam, a materials product manager at Formlabs, and I'm super excited to introduce the new Tough family of SLA resins that you just saw. The Tough family has 3 new high-performance materials: the new Tough 1000 resin, the new Tough 1500 resin, and the new Tough 2000 resin. Let's dive in and take a look at each of these materials. Tough 1000 resin is the most ductile and impact-resistant material in our Tough family. It has comparable strength, stiffness, and toughness to high-density polyethylene. It's designed with exceptional wear and fatigue resistance for long-term toughness and utility. Tough 1500 resin was released this past spring and blends strength and stiffness with toughness and ductility. It is most comparable to polypropylene, offering exceptional resistance to fractures, impacts, and shattering. Tough 2000 resin is our strongest and stiffest tough material, and our most popular engineering resin today, with strength and stiffness comparable to ABS. The new Tough 2000 resin builds upon this success with high temperature and creep resistance. Since its release this past spring, the new Tough 1500 resin has been a huge hit. With twice the adoption compared to the previous generation, more users are leveraging the superior performance to solve new problems. One of these users is Viking Yachts. Viking is using the material to produce end-use parts, like bezels, vents, and switchgear for their yacht interiors. After painting, these parts are indistinguishable from injection molded parts in aesthetics and performance. To understand what a jump these materials are, let's take a look at the progress Formlabs has made in terms of material performance over the past decade. One common way to look at material performance is to plot elongation at break against tensile modulus. Tensile modulus is a measure of stiffness, and this value is where the tough materials get their name. So, Tough 2000 is twice as stiff as Tough 1000. When we look back at early Formlabs materials, like the first version of Clear, they barely made it off the x-axis. As Formlabs has grown over the past decade, we've pushed the performance front outwards. We've created an unparalleled, versatile range of SLA materials, from 100% silicone to strong and rigid filled plastics. Adding in common thermoplastics, we can see that the Formlabs SLA portfolio, while diverse, lacks the property set to seriously challenge thermoplastic materials. But today, we can see that we finally bridged this gap. We now have a portfolio of SLA plastics that have the mechanical performance to one-for-one replace thermoplastics in a wide variety of applications. Presenting the new Formlabs Tough family, bringing additive manufacturing closer than ever before to thermoplastic material performance. All three materials are available globally today. I am so excited to see what our users will accomplish with these materials next. All right, that's enough charts. Let's compare material performance by breaking some stuff. That was incredible. Next, I want to talk about post-processing. Let's see if I can tell you about our newest hardware product in less time than it takes to cure a part. To reach final material properties with SLA resins, they require post-curing. Last spring, we made strides in post-processing when we introduced the new FormCure, which dramatically cut post-processing time for functional parts. Today, we're excited to introduce FormCure-L V2. It cures 19% larger parts with a 26% smaller footprint. You can now cure large parts in as little as 60 seconds. For advanced materials that require curing at elevated temperatures, the new Cure-L heats up to 60 C in as little as 150 seconds. With more than 45 pre-programmed cure cycles and an easy-to-use touchscreen, it's fast and easy to go from print to functional part. The launch of FormCure-L V2 completes the Form 4L ecosystem, enabling the printing and post-processing of parts faster and easier than ever. And my time is up. As you can see, my part is fully cured and ready to use. FormCure-L V2 is available to order globally today. We can't wait for users to experience the workflow improvements firsthand. And now, I will pass to Alex McCarthy to share some exciting improvements to the form and finish of parts.
Thanks, Adam. My name is Alex, and I'm on the engineering team at Formlabs. One thing we've learned is that it takes as much effort to make beautiful parts as it takes to make functional parts. If you look around, we're surrounded by colorful plastic products, from consumer electronics to power tools to home goods. With its wide range of material options, 3D printing has been an incredible tool for prototyping these plastic parts. But until now, accurate color has been hard to achieve. Formlabs has led the industry in making materials available in custom colors. First, with the Color Kit Resin, which allows customers to mix their own pigment recipes to achieve a wide range of colors. And second, with the new Color Resin platform, available as a limited release in the United States. With this new platform, we mix custom colored cartridges at our factory and ship them straight to your door. Check out these 3D printed drill housings we've reproduced in a range of vibrant colors. If you recognize these as popular brand colors, you've guessed correctly. You can see how well they compare to their actual injection molded counterparts. Renowned brands like RadioFlyer are already producing color-accurate and functional prototypes that better reflect their final products. Next, let's talk about something else that has a big impact on the quality of your final part: supports. Supports are essential in SLA printing, but they come with trade-offs. They can leave marks, take time to remove, and often force you to choose between surface finish, print speed, and post-processing effort. That's why I'm excited to announce Supports V2. our second-generation support system built from the ground up to redefine surface finish, dimensional accuracy, and ease of use all at once. Let's start with surface finish. Supports v2 uses touch points that are up to 50% smaller. It actively avoids placing touch points on flat surfaces so you can spend less time sanding and worrying about part orientation. It also intelligently places touch points along edges and corners. The result? Smoother surfaces, sharper edges, and assemblies that fit together perfectly. Next, let's talk about dimensional accuracy. The new supports analyze each model to identify the critical features and surfaces to stabilize, placing more touch points where they're needed and fewer where they're not. Across our testing with challenging customer models, Supports v2 cut dimensional inaccuracy in half. Finally, we also tackled support removal. The new supports use a crushable lattice structure that makes it trivial to desupport your parts. This lattice structure, combined with tiny touch points, makes it less likely for you to break your parts in the process. Supports v2 takes us another step closer to our vision of making any part at the push of a button, delivering the best part quality possible in SLA. They're the default supports for our new Tough 1000 and new Tough 2000 resins, and are available as a preset for gray, clear, black, and white. We'll be expanding Supports v2 to additional materials in the coming months. Next, let's talk about finish, and how the new selective face texturing tool in PreForm brings even more design intent into every print. With this tool, you can apply 3D texturing directly to specific faces of your part, adding grip, contrast, and character without ever leaving your print setup. Now I'll hand it back over to Max to close us out.
I'm so excited for all of you to get your hands on the products we announced today. Each of these products brings us closer to our vision of a future where we can all make any part at the push of a button. We still have a lot of work to do to get there, but we're closer now than ever before.